Would you describe a population with a mean of 36, a median of 33, and a mode of 32 as positively or negatively skewed? It's either symmetrical, it's positively skewed, it's negatively skewed, or cannot be determined from the information given. All right, so if we wanted to look at a symmetrical distribution, with a symmetrical distribution, very typically your mean, median, and mode are all equal to each other, but they're not here. The mean is 36, the median is 33, and the mode is even smaller at 32. So it's not symmetrical. Positively skewed, negatively skewed. The way that you determine those is by looking at how the values, where the values sit in relation to each other. Now, first of all, we have to identify that this one is what's called positively skewed, and this one is negatively. The way that I remember it is I think about a number line. So a number line has 0 in the middle, and then numbers go into the positives, and back here numbers go into the negatives. And if you think about these as being like arrows, so if you think about this as being like an arrow, it's pointing back towards the negatives, whereas this one is pointing ahead towards the positives. So that's how I keep track of what's positively and negatively skewed. Now, do we have positive or a positive or negatively skewed distribution here? Well, the quick rule of thumb that I use is that you should look basically just at the mean. The mean gets pulled towards wherever the skew is. So the mean is a higher value than both the median and the mode. So it's being pulled this way. My mean is higher than the median and finally the mode. I have a positively skewed distribution. That's how I work it out. If the mean had been much smaller than the other two, I would say that it is negatively skewed.